Almost 16.
All
right, go ahead, Brett.
Just have started.
It started?
Yeah.
Oh, you guys missed it.
That's exactly why I started it early, because I don't know any of that.
All right, so we're on example 6. We're continuing from yesterday. Yesterday we introduced the addition and subtraction identities. So example 6 says, my marker died. That's what example
Stop
6
pressing so hard on the.
That's what example 6 said.
So, you want to put down?
You come here. So how do you ladies know?
Alright, so example 6 says cosecant of angle x plus pi over 2. And then it says to rewrite that in terms of sine and cosine. So this is an addition one, but this doesn't follow one of the identities that we had, right? We only had identities for sine, cosine, and tangent.
What is cos?
So, exactly. So how do we rewrite cosecant in terms of sine and cosine? Or sine or cosine. So it's 1 over sine. So now we're going to have 1 over sine of this addition. So now we have one of our identities that we can rewrite this as. So we're going to have 1 over, rewriting this using the sine addition identity. So that said sine of our first angle times cosine of our second angle plus sine of our second angle times cosine of our first angle. So now we don't know what this x value is, but we do know how to find the cosine of pi over 2 and the sine of pi over 2, right? So we're going to simplify this now. So we're still going to have 1 over. We still have that sine x, because we can't do anything else with that. And then we're multiplying by what cosine of pi over 2 is. What is cosine of pi over 2? 0. It's 0. Remember that pi over 2 is up here. That's our pi over 2 angle. So that goes back to knowing that this is 0, 1. And we know that cosine is in terms of our x value, and our x value is 0. So we're multiplying by 0. Then we're adding. We have sine of pi over 2, which is 1. That goes along with the y value. And then we're multiplying still by cosine x.
So it's just cosine.
So now we can simplify this so that, yep, we'll have 1 over cosine x. And then can we rewrite that? What is that? That's just secant x. So solving for that, we end up with secant x. So if you're ever given one of the 3 trig functions that aren't in sine or cosine, you're going to rewrite them so that you can use them. So that you can still use the identities. Alright, so now we're going to look at example 7. And example 7 tells us that cosine of some angle equals -1/4. And then we're also told that that angle that we don't know is between pi over 2 and pi. And we're told to find cosine of a pi over 6 angle minus that unknown angle. So we're given 3 pieces of information that we have to use. So let's rewrite this using our identities first. So this is the cosine subtraction identity. So that tells us that cosine of what? Of our first angle times cosine of our second angle plus, remember that the signs are switched, sine of our first angle times sine of our second angle. So that's what we're going to have to solve, is that equation. Now we have to kind of figure out what this x is. So we're told that x value is between pi over 2 and pi. So where does that tell us we are? We're in what?
Second.
We're in the second quadrant. So if we're looking on our graph, we're over here somewhere. Right? Our angle is somewhere over here. So we're then also told that cosine of that angle equals -1/4. So if we know the ratio for some angle, can we label this triangle? Yeah. What is this definition for cosine? What does this mean? So this is our adjacent over our hypotenuse. So if we look over here at our triangle, we have our random angle x right here. That's in the second quadrant. And we know that the adjacent side is -1 and the hypotenuse is 4. So we can label this -1 and 4. Can we find our third side? We're going to use the Pythagorean theorem. So we know that -1 squared, we'll call this y, plus y squared equals 4 squared. So we're going to have y squared equals 15, y equals root 15. So now instead of having a y value up here, we have a root 15. So we didn't actually find our x value, but we can use it now to find this sine x and this cosine x. So when we simplify this, what's cosine of pi over 6? It's what? Root 3 over 2. Now what's the cosine of that angle that we just labeled the triangle for? So our cosine is our adjacent over our hypotenuse, which was actually given to us in the problem. So we know that that's multiplied by -1 over 4. And then we're adding that to the sine of a pi over 6.
Never mind. We're good.
You're good? So what's the sine of a pi over 6 angle?
1 over 2.
1 over 2. And then we're multiplying by the sine of this angle that we defined the triangle for. And that's root 15 over 4. So now we can simplify this just like we did yesterday. We're going to multiply our fractions across, so you're going to get negative root 3 over 8 plus root 15 over 8. We have the same denominator, so we can combine those. You can actually reorganize this if you don't want the negative out front, but you could write negative 3 plus root 15 or root 15 minus root 3. Either way works. So we end up with that exact answer. So when you're given questions like this, make sure that you're using all the information that they provide for you. All right, so then we have example 8. Example 8 is kind of similar to what we just did here, except this time we're given kind of weird values. Okay, so example 8 says that sine of some angle x equals 0.8. And then we're told that the sine of some angle y equals the square root of 0.75. We're told that angles x and y are in the first quadrant, and then we're asked to evaluate tangent of x minus y. So again, it's probably best if we rewrite this in terms of the identity. So this is our tangent subtraction identity, and that told us that tangent of the first angle minus tangent of the second angle divided by 1 minus tangent of the first angle times tangent of the second angle. So again, we're given information about each of those angles. Yes. Ah, yes, thank you. Should be a plus on the bottom. Thank you, Shmaya. So now we're going to do like what we did with the cosine equal to negative 1/4 in the previous example. We're going to define two triangles. This time we have angle x and we have angle y. So for angle x, we know that they're both in the first quadrant. So we have a first quadrant angle for x. This is angle x. And then over here, we have a first quadrant angle for y. So for angle x, we're told that sine of x is 0.8. How can we use that to label our triangle?
Put them over imaginary 1.
So we can put it over an imaginary 1. So if we're looking at our triangle, I can label the opposite side as 0.8. And then what's that 1?
Hypotenuse.
That's my hypotenuse. So again, can I find that third side? So again, we're going to use the Pythagorean theorem. We're going to have 0.8 squared. We'll call this z for right now, just so we don't confuse it with our angle x. So plus z squared equals 1 squared. So you end up with z squared equals 0.36. Because you're going to get 0.64 for that 0.8 squared, 1 minus 0.64. Then you're going to square root it, so you're going to get z equals 0.6. So our z here is going to equal 0.6. So how about our angle y? What can we do if we know that sine y equals root 0.75?
Put it over imaginary 1.
So we're going to do the same thing. We're going to put it over an imaginary 1 and label our triangle. So our opposite is that 0.75, and our hypotenuse is 1 again. So again, we're going to find our third side. We can call it z again. So we're going to have root 0.75 squared plus z squared equals 1 squared. Solving for z again, we're going to end up with z squared equals 0.25. So z is going to equal 0.5. So we now have two triangles with angles, so we can find tangent of each of those angles.
Yes.
So what's tangent of my angle x?
0.8 over 0.6.
So I have 0.8 over 0.6. And then we're subtracting that from my tangent of my angle y, which is
Root 0.75 over 0.5.
root 0.75 over 0.5. And then that's all over 1 plus tangent of our first angle we found. So that's plus that 0.8 over 0.6 times the tangent of our second angle was that root 0.75 over 0.5. So now we have a lot of fractions, but if you're using the Inspire, you can actually plug this in just like this. This one you're going to actually have to use a calculator for, because we're going to get an exact answer. So out of all the problems that we've done, this is the only one that requires a calculator. Ladies. So when you plug this into your calculator, you should get negative 0.1204. So the tangent of those two angles subtracted is negative 0.1204. So again, make sure that you're using everything they give you. And then our final example is going back to proving an identity. We're going to use these new addition-subtraction identities to now prove another identity. Is everybody good with this? I see some people still writing, so.
Do we get to use the calculator on the test then?
If I give you a problem like this, you will be able to use a calculator, yes.
Don't forget to talk about the.
I will. All right, so example 9, we're proving this identity. We're told sine x times cosine y equals 1/2 times sine x plus 1 plus sine of x minus y.
Are those, is that like an absolute value or no?
No, those are just brackets.
Okay, because they've already got parentheses on the inside?
Yep, it's
Okay.
just, it's 1/2 of that entire quantity.
Okay. Are we ever gonna see like absolute values for these or no?
Probably not.
Okay.
Okay, so just like we proved other identities, we want to pick one side to work with. For these, it kind of makes it obvious. You want to expand the additions and subtractions using the identities that we know. So we're going to start with the right-hand side. So we're going to have 1/2 times, and then if you want to keep each identity separate, put it in parentheses so that you can tell what each term is. So expanding out the sine addition, you get sine x cosine y plus sine y cosine x. And then we're adding that to the subtraction identity, which says sine x cosine y minus sine y cosine x. So given that, what can we do?
We can do the whole, like, factor, well, no, like,
Can you
minus.
like cancel
So what can we
out.
combine, Jasmine?
You can combine sine x cosine y and then the other ones or.
Okay, so we have a positive sine y cosine x,
I don't know.
and then we have a negative one. So those two are gonna cancel out.
Yeah.
And then we have a sine x cosine y and another sine x cosine y. So we're gonna have 1/2 times 2 sine x cosine y.
So you get rid of the bracket.
So, yeah, so we can get rid of the bracket now.
So you can just take 1/2 out of it and it becomes sin cosine y.
So when you multiply these two through, they cancel out, and you end up with just sine x cosine y.
Yay.
And that was what we were trying to prove.